Congruence, CPCTC. This is the last day we're going to talk about triangle congruences. We've talked so far about side, 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 side angle sides, angle, angle sides, angle, side angles, HLs. Talked about all those different things, right? We're going to use all of that today, tie it into what is CPCTC. And then tomorrow we will review all of this again, because I realize there's a lot of different abbreviations, and some of us are still looking at how some of the abbreviations work. But again, today we're going to do kind of some informal proofs just showing this. All stuff that you've been able to do. The only difference today is it's just asking, why are you doing that? That's all it is. CPCTC, this is what we're talking about today. This stands for corresponding parts of congruent triangles are congruent. So corresponding C, parts P of congruent C, triangles T are congruent. What that means here, if I can get up here, is if I have a triangle, and that triangle is, let's say, ALY, and I have another triangle, and that triangle is, let's say SUT. Okay. Well, if I'm telling you that triangle ALY is congruent to triangle SUT, the CPCTC, this right here, means all the corresponding parts of that triangle are congruent. So if the triangles are congruent, that means angle Y is congruent to angle T. That's what that's saying. So it's saying, yeah, angle Y is congruent to angle T. It's saying AL is then congruent to SU. All those individual parts of the triangles are congruent. That's all CPCTC means. Is after you prove the triangle is congruent, every part of that triangle is congruent. All it is.
How come we don't have color and you do?
It's just the app. You can do different apps have different colors. Alright, so here's what we're going to look at today. Is informal proofs like this. So corresponding parts of congruent triangles are congruent. All we're going to do is we're going to prove these triangles are congruent. You've been doing that all along. The only difference today is it's making you say what parts are congruent. So instead of just looking at it, it's making you take a couple extra steps on it. This is everybody's favorite part, the given part, because that is what you do not have to prove. You know that. Why? Because it is given to you. So for example, AD is congruent to CD. When I go down here to explain that, all I have to say is that is given to me. That's my explanation. It's given to me. I know that. And that is marked up there. If you see that. AD is congruent to CD. That's part of the given parts. The next part there. AB is congruent to CB. That is also given to me. I know that to be true. Is everybody with me so far? Those parts are both given to me, so my explanation is it's given. Now there's one other thing. There's one thing we don't know about the triangle. What's the one part that we don't know that we can find though? What is it, Autumn? The middle. What about the middle? It's the same. That's right there. That's that whole same line.
Coinciding.
Coinciding is another word. Nice job. Now, they will sometimes use reflexive property, so recognize that. That's the same thing as reflexive property. Okay? So, if you were to explain that these two triangles are congruent, what shortcut would you use? How would you know the triangles are congruent, Jake? So what three letters is that then? Very good. We would have SSS, which is what is shown here. So it's asking you why the triangles are congruent. Well, because of SSS. So here's the new part. Right here in yellow is the new part. How do we know angle A is congruent to angle C? Because of our new postulate that we just learned, our theorem, congruent parts of congruent triangles are congruent. So the last step of almost everything we're doing today is going to be CPCTC, which means all those individual parts are congruent. That's all it is. Okay, we're going to go through step by step through a lot of these, And it's just going to ask, why is that congruent? Well, because it's given to me. It shows it. I mean, you're just going to use explanations. Yes, Morgan. So let's look at number 1 here. And I'm going to use a lot of different colors and kind of show you what matches up. All right, I want to complete the proof here. So this one is given to me. I am given angle PNQ is congruent to angle LNM, and PN is congruent to LN. And then also note N is the midpoint. So I'm going to start off here. And you go step by step, one part at a time. So angle PNQ and angle LNM. How do I know those two are congruent? Because it is given to me. That's that first part right there. That's given to me. Okay. Next part. PN and LN are congruent. How do I know those are congruent? Because it is given. So in A, I'm going to put my explanation is it's given to me. Now I got to fill out something new. This says N is the midpoint of QM. N is the midpoint. What does that tell us about the triangles up there? What's that tell us about some of these side lengths? Who knows? What's that midpoint mean to us? What do you say, Darren? What's in the middle? N. So what's that tell me about QN and NM? They're the same. So I know those are the same. So I'm going to say in B, I'm going to say QN is congruent to NM. QN is congruent to NM. Now, if I look here, go back to orange here. What's my triangle shortcut that says the triangles are congruent? It even says it there already. What triangle shortcut is that, Emily? SAS. So I'm going to say triangle PQN is congruent to triangle LMN. Does everybody see that? All I did was state the two triangles are congruent. We've done that already. And then the very last part. PQ is congruent to LM. Why? How do we know those two are congruent? Because what's our favorite thing we're going to talk about today? What's 5 letters? CPCTC. Nice job. All right, next one here. Let's try another one. Now this would be what is called a 2-column proof. Same thing. We're just going to fill in the blanks. Okay? So I am given this information. Triangle UXW and triangle UVW are right angles. Right triangles. UX is congruent to UV. Okay, I'm given that information. So the first part here says UXW and UVW are right triangles. So I know this is a right angle. So what else is a right angle? The one right next to it, right? Those are both right angles. Is everybody with me so far? Both right angles. Good. I know that UX is congruent to UV. What is my reason for that? How do I know that, Yanni? It's given to me. So for my reason, I put given. Don't have to say anything else. That's given. UW. Now we're down here. UW is congruent to UW. How do you know that line is congruent to itself? Why, Amy?
Because they're same line.
Same line. What property does that? Does anybody know? Starts with an R? Reflexive property. Nice job. That's the reflexive property. You can put same line though. That's okay. So now what's going to come in here? Do I know my two triangles are congruent now? Yes. So triangle UWX is congruent to triangle. If I said UWX, what's that going to be congruent to, Tyler? Nice job. UWV. And what shortcut gives me that? Now think about it. It's a specific one. We talked about it yesterday. What is it? This is HL. Nice job. Because I have a right triangle and I know the hypotenuse and a leg. So that is the HL theorem there. And then the very last part, angle X is now congruent to angle V. Y CPCTC. Right there. Typically. Typically it will be. Yep. Alright. Try one on your own here. There are 3 spaces or 3 boxes or 3 letters to fill out. Put in your information. Alright, so let's walk through this here. Now, number 2. Alright, let's look at this. Number 2 here. What's going to go in place of A, Cassie? Nice job. QS is congruent to QS. And how do you know that? What? It's the same line. Yeah. That's all it's doing, is just asking you to prove it. Well, QS is congruent to QS. You just state that. Okay, now what do I know, Nathan?
On the PS is congruent to SR.
Not there yet.
Oh, okay.
I'm at where the triangles are congruent. Because SAS. So now what do I state? Darren? Nice job. Anytime you see this right here where it gives you one of the abbreviations, that's where you got to put in what the triangles are congruent to. That's where you got to fill it out. It's kind of just like matching. You see what goes with it. That's where we put our triangle part. Now the last part. How do I know angle P is the same as angle R then? Emily? Huh? Are the triangles congruent? So what do I know if the triangles are congruent then? About all of the congruent parts of the triangle. What do I know about it? Tiana? Yeah. If the triangles are congruent, all of the parts of that triangle are then congruent. That's all that is saying. Okay? Once you have the triangles are congruent, the last thing you're almost ever going to do on every assignment you do today is say CPCTC. Yes, ma'am. Okay. All right. Next, we're going to talk about the coordinate plane here. All right. We can prove triangles to be congruent in the coordinate plane as well. Now, we can use the distance formula. We can also use Pythagorean theorem. What is Pythagorean theorem? Who remembers it? Very good. A squared plus B squared equals C squared. You can use either of those to find the side lengths of the triangles and show they're congruent. For example, like HG here, what's the distance of HG? Counts, a vertical line. Isabel's? 4. What's the distance from E to D? Isabel's? 4. I can count those. Those are given to me right there. Okay, they kind of works it out. And then I find the distances of the other. Now that's really the square root of 20. Those are just simplified. Okay, so I can find all of the distances. And once all the distances are found, I'm checking to see if they are the same. Are all of the distances the same for each of them? Yeah. So then I look down here. And how do I know the triangles are the same? Because of side, side, side. Because I found all of the sides of that triangle. So side, side, side says all of the triangles are the same. And then you can take it a step farther and still say, well, angle C is congruent to, or angle E is congruent to angle H because of CPCTC. Okay, so let's go on to number 4 here, and we're going to find some lengths. So looking at the two triangles, number 4, give me a side that you would like to find first. Joe, what's the side length? Which side would you like to find first? Doesn't matter. Which one?
RS.
I like that one. Why? 'Cause it's just right the horizontal line, right? So what's the distance for RS, Joe? 7. Now, if I were to look at RS, which other one is very similar to RS? Or which would RS probably match up with? Would you say, Ezra? XY. So the distance for XY is what, Ezra? 7. Good. So those are the easy ones, right? Because they're vertical and horizontal lines. What's another one that you would like to find, Yanni? Which one? WX. Can we use Pythagorean theorem on something like that? Yeah, I can make it a right triangle, right? So I have a distance of 2. I have a distance of 3. What's Pythagorean theorem again? Anybody remember? A squared plus B squared equals C squared. Nice. So 2 squared is 4. 3 squared is 9. 4 plus 9 is? So I get the square root of 13. Oops. I'm on the wrong side. So WX is the square root of 13. Well, which one is WX going to be the same as, would you say, probably? RQ, right? So can I use Pythagorean theorem again? Yeah. And again, you can use distance formula and all this too. It's all the same. I have a distance there of 2, a distance there of 3, which means RQ has a distance of 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. I get the square root of 13. All right. Last one here. What's the last segment I need to find on either triangle, Amy? Doesn't matter.
QS.
Let's go QS. Can we use Pythagorean theorem again, Amy?
Yep.
I have a side length of 5 and a side length of 3. 5 squared is 25. 3 squared is 9. 25 plus 9 is 34. I have the square root of 34. I'm going to erase so I have some room here. And then I have WY. Can I use Pythagorean theorem again? You bet. So I have a distance of 5, distance of 3. 5 squared is 25. 3 squared is 9. 25 plus 9 is square root of 34. Are my side lengths the same now? So what congruence shortcut says the triangles are congruent? What's my congruence shortcut? It would be side, side, side. States that is congruent. Good job. Take a couple seconds. Try number 5. Find all of the distances. All right, let's start walking through some of these distances. Emily, what's the distance from A to B? Oh, square root of 25? What's square root of 25, anybody? 5. Good. So I agree. AB is 5. What's JK then, Emily? Five. Good. What about BC? So that was AB and oh wait, not that. AB and JK. What about BC? What's the distance for BC, Tech? Square root of 10. Good. LK is what, Tech? Square root of 10. Good. And the last one, Darian, what's CA? Or AC, either way. Do you have it? Anybody? Nate? Square root of 53. Nice. And then LJ is also the... Are my sides all the same? Yes, they are. What congruence shortcut would say the triangles are congruent then? Side, side, side. Nice job. Okay. Still got a hang of that? Do you find distances? Good. Try this one here. This one shouldn't take you too long. Most of the distances are vertical or horizontal lines. Okay. Take a couple seconds, plot the points, and then use the distance formula to find the missing parts. All right, let's start going through the distances here. AB. Who has the distance for AB? Jace, what was it? 3. Nice job. What about XY, Jace? 3. BC was probably the tougher one up there because that was the one that wasn't a vertical or horizontal line. What is the distance for BC, Darian? Ezra? 5. What was YZ? Also 5. And what about AC? Joe, do you have AC? And XZ? My triangles are congruent because of what shortcut? Or Darian? Side, side, side. And the last part. Angle X is congruent to angle Y. How do I know those angles are now congruent? Because of CPCTC. Very nice. Here's our assignment.